Hello, and welcome to our presentation on the fundamentals of 3D equilibrium analysis for rigid bodies in structure system. This is presented by Group 14, which is us, as part of the BDA 10203 course, under the supervision of Associate Prof. IR Dr. Muhammad Kir bin Muhammad Noor. So, as you can see from the slide, there are five of us that doing this mini project. And the first one member, which is me, and I will introduce myself. My name is Samil Gawe Ananon, and my metric number is CD240087. So, let's move on our overview, which is including introduction, real life problems, mathematic modeling, discussion, and conclusion. So, for the first one is, what is static? I will give you a simple briefing about statics. Statics is a branch of mechanics that examines forces in equilibrium. In simple terms, this means systems that are either stationary or moving at a constant velocity. Using mathematics and Newton's law, statics helps us understand how forces interact with structures, materials, and machines. This understanding is essential for designing safe and efficient systems. So, let's move on to Newton's law of motion, which is the simple and the basic law that we learn in this course. There are three laws, which is first, second, and third law. For the first law, which is a body remains at rest or in uniform motion unless acted upon by an external force. For the second law is the force acting on the body is equal to its mass multiplied by its acceleration, expressed as F equal to ma. And lastly is third law. For every action, there is an equal and opposite direction. This principle sets the foundation for analyzing equilibrium in system. So, there are important notes that need to be ensured and involved in this mini project, which is equilibrium theory, uh, moment of force, and vector component in 3D. So, we move on to problem statement. In statics, we analyze system or rigid bodies in equilibrium. Unlike dynamics, which focus on system in motion, statics examine system where all forces balance, resulting in no net motion. In chapter 3, the focus is on the equilibrium of rigid bodies in 3D space, where forces and moment along the x, y, and z axis must sum to zero. This involves using equations for moment and force analysis, just like the important notes that I have mentioned just now. So, the main objective for these studies are know how to solve an equation related to chapter 3 by applying several steps to prove that the system is in equilibrium. Second, understand the concept about calculating forces in three-dimension mode, which is in respect of three axes, and how to use an equation related to calculating force in respect of x, y, and z axis. Next, learn the structure of any system or rigid body in respect of this chapter. And lastly, to get understand and get used to read and define the problem related to this chapter.
Hi, Assalamualaikum. Okay, now my name is Muhammad Hafizuddin bin Muhammad Rizal. My number matrix CD 240215. Okay, now I want to review life problems. Okay, we have 5 examples. Okay, which is number 1, ladder. Okay, stability issues. Ladders may become unstable and uneven or slippery surface, increasing the risk of tipping over. Okay, number 2, improper usage. Using the wrong type of ladder, example, a step ladder when an extension ladder is needed, or overreaching can lead to accidents. Okay, number 3, weight capacity. Overloading a ladder beyond its weight limit can cause it to break or collapse. Okay, example number 2, thrust. Material defects, variations in material strength, or defects in joints and members can lead to unexpected failures in trusses. Okay, number 2, improper load distribution, incorrect application of loads such as concentrate loads and unsupport points can cause uneven stress distribution and structural failure. Okay, number 3, buckling in compression members. Truss members in compression can buckle under high loads, especially if their slenderness ratio, length to weight ratio, is high. Okay, I will continue 3 more review life problems. Okay, number 3, traffic light pole. Okay, first, physical damage and vandalism. Traffic light poles unsusceptible to damage from vehicle collisions, weather conditions, storm, lightning, and acts of vandalism, leading to costly repairs and operational downtime. Obstruction of pedestrian pathways in urban areas. Poorly placed traffic light poles can obstruct pedestrian movement, especially for people with disabilities or those using wheelchairs. Okay, number 3, rust and corrosion. Over time, traffic light poles, especially in areas with high humidity or pollution, can experience rust and corrosion, weakening their structural integrity and increasing maintenance costs. Okay, example number 4, bridge. Traffic congestions, insufficient lanes or outdated designs can cause traffic bottlenecks, affecting travel efficiency and increasing accident risk. High maintenance costs, frequent repairs, especially for large or iconic bridges, require substantial financial resources and can disrupt transport. Okay, number 3, design flaws. Inadequate initial designs or material choices can lead to premature failures, as seen in some historical bridge collapse. Number 5, crane. Mechanical failures. Cranes experience breakdowns or malfunction due to wear and tear, lack of maintenance, or design flaws, leading to delays or accidents. Okay, number 2, overloading. Operating cranes beyond their rated capacity can cause structural failure, tipping or collapse, endanaging workers and property. Okay, next, and lastly, weather condition. Cranes, especially tower cranes, are vulnerable to high winds, lightning, or extreme weather, which can impact stability and safe operation. That's for me. Thank you.
Assalamualaikum, my name is Azamuddin Yahya. So today I will explain why we choose this problem. So we choose to solve this problem with the understanding that we have learned from chapter 3, equilibrium of rigid body. This chapter is important because it is the basis of solving real-world engineering and structure problems. First, fundamental principle. In this subject, we learn about the basic equilibrium principle such as balancing force and moment. This principle is important for analyzing static in system. All the force and moment with respect to any point must be zero. Second, practical application. This concept allows us to apply theoretical knowledge such as designing stable structure or analyzing force, load and moment. Next, problem solving framework. Systematic methods such as free body diagram and equilibrium equation serve as a robust framework to solving engineering problems. Last but not least, accuracy and reliability. Applying this principle is to ensure that our solutions are accurate and reliable. Safety and efficiency in engineering design are the most important things.
Assalamualaikum and good morning. My name is Muhammad Amin Hilman bin Muhammad Shafiq So. My matrix number is CD240308. So for today, I want to explain about how to solve the problem for 3D equilibrium analysis for rigid bodies in structural system. Okay, so firstly, we need to define the problem. So carefully read and interpret the problem statement, then identify the rigid body to analyze and the forces and moments acting on it. Lastly, we need to identify the type and location of supports or constraints as they dictate the types of reaction forces and moments. Okay, then secondly, we need to draw the FBD, sketch the rigid body and removing any supports or connection based on the question. Replace supports with reaction forces and moments. Okay, and then we need to define a coordinate system. Write all forces and moment in Cartesian vector form. Okay, then next. Okay, next, we need to apply the equilibrium equation. So we need to apply force equilibrium equation, which is Fx equal to 0, Fy equals to 0, and Fz equal to 0. And then for the moment equilibrium equation, Mx equal to 0, My equal to 0, and Mz equal to 0. Okay, then we need to calculate the moment. Use the position vector r to calculate moment caused by force M equals to r multiple with F, where M is moment vector, r is position vector, and F is force vector. Okay, and then we solve the system of equation. So we need to create a system of linear equation, and then we solve for the unknown reaction forces and moments. And then if there are more unknowns than equation in the system, we need to create a new equation. If the system is solvable, solve it step by step by substituting known values. Okay, and then lastly, we need to verify our assumption. We need to ensure that the calculated moments and reactions correspond with the problem's physical constraint. Okay, and then, okay, so for result analysis, here is our question. Okay, from the diagram, determine the pipes component of reaction at the fixed support at A. So our solution is, we need to draw FBD and then write the forces in Cartesian vector notation. And lastly, we need to apply the equations of equilibrium to solve for the unknown moment. Okay, so this is my calculation for our question. Okay, so firstly, we need to draw the FBD and then put all the forces and the distance to make it easier for me to calculate it. Okay, and then I use the submission of forces to get the forces at A for every axis, which is AX, AZ, and AY. Okay, and then I convert it to Cartesian vector form for the distance and the forces. And then after that, I use the cross product method to get all the moment in every axis. Okay, then after that, I gather all the value to calculate the moment at every axis, like max minus with 687.5 minus with 812.5 for x, and then after that I get the answer for the MAX is 1500 Newton meter, and for MAY I got 935 Newton meter, and MAZ is 0 Newton meter. Okay, that's all for me. Thank you.
So for the discussion, the analysis of the reaction at feed support on pipeline is quite difficult due to several factors. Among them is the force and distance of the pipeline. If the distance taken along the pipeline is not accurate, then it will affect the result of the analysis. In addition, static principle usually assume a stationary system. For example, this pipeline refer to the study of force, moment and effect on it. Improving pipeline design is essential to improving safety, reliability, efficiency and environmental sustainability. A design that supports even distribution of static loads along the pipeline can prevent localized stress and potential failure points. The principle of static is used when force and moment acting on a system or structure such as building and bridge need to be in equilibrium to prevent collapse or deformation. Additionally, in structure engineering, this principle is also for designing structures that are stable under dead loads, live loads, and environmental force. Next, static are applied to machine components such as gear, shaft, frame, and supports. For example, lifting machines such as crane, hoist, or elevator can lift heavy loads without tipping over and breaking.
Assalamualaikum, my name is Nurina binti Anwar and my matrix number is CD240205. And for the conclusion in this mini project on the equilibrium of the rigid body in 3D, showed how important it is to understand and apply the basic rules of statics. These rules help us study forces and moments acting on rigid body to make sure they stay stable and balanced. In this project, we learn how to solve problems step by step. So firstly, we need to understand the problem first, and then we drew the free body diagrams, which is FBD, and then we use equation to find equilibrium, and finally, we solve for unknown forces and moments. These steps are very important in designing safe and strong structures like building, bridge, and machine that can handle forces without breaking or collapse. So the project also showed how helpful tools like free body diagrams and Newton's laws are in solving real-world problems. Free body diagrams make it easier to see and understand the forces and moments acting on a body. Newton's law, especially the laws of motion, help us understand how rigid bodies stay in balance. Together, these tools help engineers solve problems with confidence and design systems that can handle different forces safely. One of the most important lessons from this project is the value of being organized when solving problems. Breaking down a big problem into smaller, clear steps make it easier to understand and solve. This approach not only improves problem-solving skills but also help develop logical thinking, which is very important in engineering. The project also showed how these basic principles are used in real-life engineering tasks, making it even more valuable. Recommendation: to make learning about equilibrium even better and more useful, some suggestions can be made. Firstly, using computer tools like simulation software can help solve harder problems faster and more accurately. Programs like SolidWorks can show how a structure behaves under different forces, making it easier to understand and improve designs. Secondly, hands-on activities like experiments, real-world case studies, and group projects can make learning more practical. For example, testing a small model of a bridge in a lab can help students see how forces act in real life. Case study about real engineering projects like the design of a tall building can also connect classroom learning to the real world. Another important suggestion is to practice drawing and understand free body diagrams. These diagrams are key to understanding how forces and movements work, but many students find them challenging. With more practice, students can learn to create clear diagrams that make solving problems much easier. Lastly, it is important to stay updated with new ideas, materials, and tools in engineering. The field of engineering is always changing with new technologies like 3D printing, advanced materials, and smart sensors offering better ways to solve problems. Learning about these advancements can help engineers design safer and more efficient systems. In conclusion, this project has shown why it is important to understand and apply the basic of equilibrium in 3D by following clear steps, using modern tools, and practicing hands-on activities. Student and engineer can improve their understanding and skills. This knowledge is essential for creating strong, safe, and efficient designs that make a real difference in the world.